All right, hi, everybody. So we're going to talk a little bit about what's going on in statics. This is our statics Moodle page. Just want to make a couple of housekeeping statements. The first is, as you can see here, we have a list of the days, Monday, Wednesday, Fridays, that we have class between now and spring break. I'll post the rest of the schedule after spring break because I'm kind of changing up the order of the chapters in the last half of the class. I've done them a couple of different ways. And it seems to work better one way than the other. So I'm going to make sure that we're doing it the way that works the best for this class. But as you can see, not every day do we have a meeting. Some days you'll be watching videos that are posted to the Moodle page. So for example, today, we did video 1, which was the one that I recorded in class on Wednesday. Today, we're having a face-to-face or Zoom meeting, which will also be recorded, and then you'll be watching lectures 2 and 3 that are posted to our Moodle page. So here's lecture 2, and here's lecture 3. Okay, what we're working on is the unit conversion handout. So after I get through this little bit of a little bit of housekeeping, we'll do a little bit of work from the handout so you can see what I would like it to look like and how your work should be. The housekeeping that I'd like to settle up with you is, if you need to have an appointment with me, please schedule through this program, which is called Calendly, but it's on our Moodle page right here where it says schedule appointment with me. And it is also on my email. I'll pull it up, but every email that I have in this underneath the block with my signature line, there's a set an appointment with me. Both of them bring you to this page. And what that will do is it will populate with the times that are available. So for example, if you wanted to meet with me next Wednesday, you can see the times that I'm available. The big advantage to using this program for me is that nobody can overschedule. Once we get that appointment set, nobody can drop by and occupy my time so that we can have that time together. Right now, I have everything set up for Zoom. We can meet face-to-face, but we'll just have to have a conversation about that to make sure that I'm physically on campus. Okay, but if everybody schedules through Calendly, then I will never have a conflict again, or at least that is my hope. So that way I can always have that time dedicated to working with you. If that's your time, we don't have to worry about anything else. Okay, so getting back to the schedule then, we're going to be working on the unit conversion handout, which I just find that students are kind of all over the place. Some people are very familiar with that. Some people are not familiar with that, but you'll be reading through chapter 1 of the textbook, which is posted to our Moodle page. And then you'll see that in chapter 1, there is no homework at the end of chapter 1. This is just definitions and some fundamental ideas that we're going to be working with, talking about those systems of units that we talked about last time, how much fun we have with metric versus US customary. So some of the factors that you need in here are available to you for working with, but then it gets down to the end. It tells you a little bit more about units, and it tells you a little bit more about numerical accuracy, and it talks briefly about significant figures, and then it gives you no homework. So that's where the unit conversion handout comes in. All right, so for our work together today, I want to take a look at the unit conversion handout, and let's open it up and do a couple of the problems just so that you see how I would like to have them done. And some of this is practice, and some of it is actually getting used to the ideas. Okay, so let's take a look at, just start with problem number 1. And I'll turn my video over here in just a minute so you can see my handwriting. But we have 16 inches equals how many centimeters? All right. So when I write that down, stop the share for a moment. The first thing I do is, if you remember, if you've had chemistry, this is a place where where you may have picked this information up. But here in our work together, we can go back and take a look at that textbook for chapter 1, and you'll see that there are a bunch of conversion factors. Now, if you have access to a different set, if you have a set of tables that you like to use or something on your phone, that's fantastic. But like I indicated to you last time, it would be very irresponsible for you or for any engineer to not refer to a table. So the purpose of this section is not to have you memorize conversion factors, but to use them effectively between one set and the other and within sets. All right, so we take a look, first of all, inches and centimeters is going to be a measure of length. So we see if we have anything that works for us. Okay, we have inches to millimeters. And so I can say from this table that 1 inch is equal to 25.40 millimeters. And then if I go up, and I know you can do this in one step, I'm deliberately going through this in a multi-step method. If you take a look at the metric system, you can see that milli and centi are off by a factor of 10. So in other words, 10 millimeters is the same amount as 1 centimeter. All right. Now, so what I've written down so far looks like this. So how does this work? Well, when we talk about a unit conversion, when we mean unit, what we mean is something that is equal to 1. So if 1 inch is exactly the same amount of length as 24.50 centimeters, that means that 1 inch over 25.40 centimeters, because these are the same amount, is equal to 1. And you know that you can divide any, or you can multiply any number by 1, and it doesn't change the value. Similarly, 25.40 centimeters over 1 inch is also equal to 1, because 1 over 1 is equal to 1. All right. So if we start with this idea of 16 inches and we want to change it into centimeters, this is millimeters, not centimeters. Okay. The first thing we need to do is to decide how we're going to make this happen. Well, if we take this unit conversion, we have inches on top here. If we put inches on the bottom here, what will happen is we've multiplied by 1, so we haven't changed the value, and we have inches in the numerator, inches in the denominator, so we can cancel them out. And then we will have how many millimeters that equals. We don't want millimeters, we want centimeters. So we do the same thing here where we say then 10 millimeters is the same value as 1 centimeter. Then we cancel this and we cancel this. All right, so to get our answer, we would take our values, 16 multiplied by 25.40 and then divide by 10. And the answer that I get is 40.64 centimeters. Okay, now that's the number that my calculator returns. The thing that we need to remember is significant digits, okay, or significant figures. Conversion factors are always considered exact. In other words, you never make a determination about the significant figures of an answer based on the conversion factors. It's always on the data that goes in. So the number 16 has 2 significant figures or 2 significant digits. That means that my answer here should have 2 significant figures. So the real answer for this problem would be 41 centimeters. Okay, now the other thing is if you were to write 40.6 centimeters, this is okay. I might make a little question mark or put a little face by it or, you know, something like that. I'm not going to lose any credit. If on the other hand, you rounded this to incorrectly to 40 centimeters, or you wrote 40.640000 centimeters, you would lose some credit on these, okay? Because first of all, this number is not correct. 40.64 does not round to 40. And this many digits implies that whatever instrument you were using measured out all these decimal places. And because this only measured to inches, that's not possible, or it's not like, it's, this number we always assume is written as it was measured. If it had more digits, they would have written it as 16.000000 inches, and then we would use that number of significant digits. Okay, so you guys have any questions about that? I didn't think you would, but you never know. All right, so I wanted to go down and do one other one, because there was one that was a little bit hard to read. So I wanted to take a look at that. Okay, first of all, number 14 here says 17 inches is equal to how many centimeters? So on the conversion sheet, 14 reads 17 inches is equal to how many centimeters? The one that's really hard to read is number 18. And it says 1.5 quarts is equal to some number of some kind of a liter. All right. Well, yeah, it's kind of a little, it looks from this perspective, and it's not because it's a terrible unit. It's just because this is not that beautiful of a copy. So if you pull it up there, I interpret that as a centiliter, which is a 100th of a liter, as you had suspected. All right, so if we say 1.5 quarts is equal to that number of centiliters, once again, we're going back and forth. Now, the first determination to decide which scale or which charts you want to use, if you look at this and you say, this is in US customary, this is in SI, then you know. Sometimes you're going to be converting just among SI units, between SI units, sometimes you'll be converting just between US customary units, but if you are converting from one set to another, then you want to find the table that goes US customary and US equivalents. Okay, so if we look here, first of all, a quart is a measure of volume. And if we go down here, we see that a gallon is equal to 3.785 liters. That gets us somewhere. Okay. But where does it actually get us? All right. Well, you could go and find out what's going on between quarts and liter. The word quart actually stands for quarter, right? So it's a quarter of a gallon. So if you have to look that up, that's great. If you just know that because you've been buying quarts of milk for a while, maybe that's okay too. But we know that there are 4 quarts in a gallon. And we know that centi means hundredth. So that means that there are 100 centiliters in 1 liter. All right, so now we have our conversion factors. We can write them as unit conversions. We start with 1.5 quarts. First, we want to get quarts into gallons. So since quarts is in the numerator here, we want to put quarts in the denominator here. And then we have gallons, and the quarts will cancel out. We have gallons in the numerator, so we want gallons in the denominator. So to cancel, 3.875 liters. And now we have liters to centiliters. So liters is in the numerator. We want it in the denominator, so we'll cancel 100 centiliters. So quarts cancel, gallons cancel, liters cancel, and we'll be left with centiliters. Okay, so what is our numeric value? We take 1.5, divide it by 4. Multiply it by 3.875 and multiply again by 100. And we get 1.5 quarts equals 145.3125 centiliters. All right, so based on our previous work, what's wrong with this answer? SIGs, that's right, we got way too many of them. This has 2 significant figures, so this answer should have 2. Since this is a 5, I'm going to talk a little bit about that, but in my opinion, 5s always round up. So that would be 150 centiliters. Or if you said 145 centiliters, I would also accept that answer. Okay. So why does a 5 always round up? Well, because statistically, we have 10 digits, right? If you're in chemistry class, it's a little different. So I want to be clear, this is just this is what I do. So don't tell your chemistry teacher that he or she is doing it incorrectly. But if you look at that, you count there 10 digits, 1, 2, 3, 4, 5. These are below the mid, these are above the mid. And so that means that these round up, 5 rounds up. Okay, now the reason for that, if you think about it, is if you knock 0 out of this and you use these and you say that 5 is in the middle and that 5 might round up and round down, what you're really saying is a 0 is exact. But when you're measuring things, a 0 is no more exact than a 1 or a 2 or a 9. So it is also an approximate number. That's why philosophically it's included in 10 digits that round instead of just 9 digits that round. Okay, and like I said, in chemistry or in other classes might be a little bit different. So you want to do it the way your teacher tells you to do it. All right. All right. So do you guys have any questions? Okay, so here's what I want you to carry out with you today after our short lecture together. If you need to talk with me, and I hope you will, because I spent a lot of time talking to students privately or in groups. But the next time that we're going to meet will be by Zoom, and it will be on Wednesday, January 25th. In other words, on Monday, January 23rd, we will not have a synchronous meeting. So you'll just do the lectures and follow the schedule. And if you have any questions, you need to visit with me, you will come to Calendly and make an appointment with me, and then we will Zoom together. Okay. The other thing is that even though we're not meeting synchronously, this room, SM-137, is available at 1 o'clock on Monday. So if you want to come in here and work together or work by yourself, you're more than welcome to, because it is available to you. All right. Do you guys have any questions for me? These are gonna be easy. I hope. No, I mean, not really. You guys can
hello, can you hear me?
make me earn my keep all I want. All right. So what I'm going to do now is I'm going to turn off the recording. And if you have any questions, I'll take your questions, and otherwise we will continue with our work. And the next time we'll see each other is on Zoom on Wednesday, the 25th. All right. All right. Thanks, everyone.
Hello?